Hello friends, welcome to our channel Fundamentals of Engineering. Now we are started to discuss regarding these permutations. Now today we are in the part 4. There we are going to discuss the problem based on the words, that the words which contains the vowels are never together, consonants are never together, or other letters which can be underlined letters that cannot be never together. So how we can arrange the words given, that we are going to see in today's session. Also we are going to discuss the odd and even places when the words are given, when we have to occupy the vowels in the odd position and consonants in the odd position, or vowels in the even places and consonants at the even places, how they are arranged, that we are going to see. So if you miss the earlier parts, in the part 1 we have seen the permutation of numbers which contain with 0, without 0. Then in part 2 we have seen the problem based on the words. There we have seen the repeated letters and non-repeated letters. Also the problem based on the repetition of letters is allowed and repetition of letters is not allowed, that we have seen. Now in this session we are going to discuss for word problem which contains vowels, consonants or other underlined letters which are never together, and if vowels and consonants occupy the odd and even places, how we can arrange that word, we are going to see. So numbers we have seen in the first part. The link is available in description box, or you can check the I section. Then in the second part we have seen the repetition. So this is will be covered in the second part, and this we are covered in the third part. Today we are going to discuss this fourth part. So hope you are with me. We'll start to discuss the part 4. So before going to discuss, every time whenever we are started to discuss regarding the permutation, we always focus upon the factorial values, because these factorial values, if you remember, that will be very helpful whenever you are solving any type of permutation or combination problems. So all the factorial values you have to remember, I given you from the 0 factorial to 12 factorial values. You can take the screenshot of all factorial values, that will be helpful to you. So you can take the screenshot. I'll wait for 1 minute. You can take the screenshot. Take the screenshot of factorial values. So if you have taken the screenshot of all factorial values, we'll move forward to see the question regarding type 4 when never together. Never together. First example we are going to discuss, when how many different ways we can arrange the following letter, following word. The word contains subscribe when the vowels are never together. We have seen the always together, when the vowels, consonants and other letters always together. Now we are going to discuss the vowels are never together. So we are having this word subscribe. It contains how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letter word. We are having 9 letter word. So whenever you want to solve the never together problem, here you have to remember one important formula. What is that important formula? So possible arrangements you will get in the never together, is equal to total number of ways you can arrange this word, any word given, minus either vowels or consonants when they are always together, how we are doing the arrangements. So this is the important formula to get the possible arrangements whenever the vowels or consonants are never together. So remember this formula. So possible arrangements we are getting whenever vowels or consonants are never together, that is equal to total of number of ways we can arrange this word minus whatever the vowels or consonants are always together we can arrange. So we have seen total number of ways how we can arrange, and when the vowels or consonants are always together how we can arrange, that we have seen. Now we will solve this example. We are having 9-letter words. Subscribe. So first we have to find out the total number of ways. So total number of ways, TNW is nothing but total number of ways. So what we have to do, we have to count the number of letters. We have to count the number of letters and we have to take the factorial. Count the number of letters and we have to take factorial. So how many letters are there? 9 letters. We are having 9 letters. But we have seen the repeated letters also. Here S is repeated twice. You can see here S is repeated twice. 1, 2, and also B is repeated twice. 1 and 2. So S is repeated and B is repeated. So whenever you are calculating the total number of ways, you have to find out whether there are any repeated letters. So we are having a repeated letters here. So total number of ways, number of letters, that is 9 factorial upon repeated letters. How many times they are repeated? So S is repeated 2 times. So 2 factorial and B is repeated 2 times. There is no any other letter which is repeated. 2 factorial into 2 factorial. So in the last always together we have seen we can't do the calculations like 2 into 2 and 4 taken the factorial values. That will be the wrong answer you will be getting. So 2 factorial for S repeated twice. So S is repeated twice here, and 2 factorial for B is repeated twice. That we have taken. So 9 factorial values. Why I have already given you to take the factorial value screenshot. Why that is important? Again, take the 9 factorial value, divide with 2 factorial into 2 factorial, means 2 factorial value is 2 and 2 into 2 4. 9 factorial divide with 4. 9 factorial value is 362880. You can see here. If you are not taken the screenshot, take the screenshot again. If you are not taken the screenshot of these factorial values, that will be helpful to you. You have to remember all these factorial values to getting the answer. So you can see here 9 factorial value is 362880. 362880 divide with 2 factorial value is 2. 2 factorial value is 2. 2 into 2 4. So we are getting answer for the total number of ways. If you divide with that, how much? 90720. You have to divide with the 4. 4 9s are 36. 4 2 0. 7 4 are 28 and 4 2s are 8. 90720. That we are getting total number of ways. Now always together. Always together. That is the second part. This is not a time consuming, but you have to understand how we are calculating. For the first word, I am taking this much time so that you will understand. Always together means vowels are always together. How many vowels are there? U is the vowel, I is the vowel and E is the vowel. So that will be always together. U, I and E. That should be always together. That should be always together. So remaining are consonants. Consonants S, B, S, C, R and B. So how many places? 1, 2, 3, 4, 5, 6, 7. 7 places. So possible arrangements when they are always together, ovals are always together. 1, 2, 3, 4, 5, 6, 7. So 7 factorial. Now see here, S is repeated twice and B is repeated twice. So 2 factorial into 2 factorial. And remaining 3 ovals, 1, 2, 3. That can be arranged with the 3 factorial values. So 7 factorial value. What is the value of 7 factorial? If you have taken the screenshot, give me the value of 7 factorial. Seven factorial value. If you have not taken the screenshot, again I am saying take the screenshot of these values. Screenshot of these factorial values. If you have taken the screenshot, that will be helpful. 7 factorial value is 5040 divided with the 4, because 2 factorial into 2 factorial 4 into 6. So you have to divide with that 5040 with the 4 and you have to multiply with the 6. So final answer you are getting 7560. You can do with a virtual calculator, whatever the calculators you are having, from there you are getting. So this is not the final answer. Final answer we have to get that subscribe word when ovals are never together. So never together formula is total number of ways minus always together. So total number of ways we got how much? 90720 minus you have to always together value 7560. So 90720, that we are getting total number of ways. Yes, Pratik, you are right. Asiya, you are right. 7 factorial value. So what is the value for this one? 90720 minus 7560. You can put that into the chat box. Put the value of this subtraction into the chat box. We'll move to further for the next question. So next, ovals are never together. How we can arrange this word channel? So what we know? So never together formula is total number of ways minus always together. So first we will calculate the total number of ways. So total number of ways we can arrange. So first you have to count the number of letters given. 1, 2, 3, 4, 5, 6, 7. 7 letters. So that will take the 7 factorial value. But n is repeated twice. So 2 factorial. So 7 factorial value you are given. 7 factorial value you are given. That is in the chat box. You can check that. 5040 upon 2 factorial value is 2. 5040 upon 2. So here 25, 20, 52, 25 to 50 and 20. Right? You are getting 2520 total number of ways. Next, always together means ovals will be always together. How many ovals are there? A and E, only 2. A and E, only 2 ovals. That should be always together, and that will be taking place in between the consonants. So consonants are C, H, N, N and L. So 1, 2, 3, 4, 5, 6 places. So arrangements will get when they are ovals are always together. So these 6 places, 6 factorial upon n is repeated twice, so 2 factorial into, these are the 2 ovals. Asiya, do the calculation. 83106, that is the wrong answer. Do the calculation again. You are getting the wrong answer. Please check that. Please check. So possible arrangements we are getting here 6 factorial upon 2 factorial, because these are the 6 places the ovals can be fixed and n is repeated twice. That's why we are divided with a repeated letter. How many times they are repeated? 2 factorial into 2 ovals that can be arranged with a 2 factorial value. So 2 factorial will be cancelled out. Remaining is 6 factorial. So 6 factorial value we know. What is that 6 factorial value? 720. 6 factorial value is 720. So never together we are getting total number of ways, that is 2520 minus 2520 minus 720. 2520 minus 720. So what is the answer? You have to put into the chat box. 2520 minus 720. That will be the final answer you are getting. That will be the final answer you are getting, and that you have to put into the chat box. Now we have seen the ovals. Now we will move towards consonants. So consonants are never together. Same formula. When the consonants are never together is equal to total number of ways minus always together. So always together we have seen in the last part. If you are not checked, you can do check. The link is available in description box. We have to do never together. Ovals are never together. Means total number of ways we are getting 90720 minus always together we are getting 7560. So based on that you are getting the answer 83160. You can check that. So here total number of ways. Total number of ways. So you have to count the number of letters 1, 2, 3, 4, 5, 6, 7. 7, that means 7 factorial. But A is repeated twice, 1, 2. 2 times that is repeated. So divided with the 2 factorial. 7 factorial value, that is 5040 divided with the 2. 2520. That is the answer whenever we are writing all the total number of ways. Second, always together. So here we are taking the consonants always together. So how many consonants? M, N, G and R. M, N, G and R, that should be together. So these consonants will be together. Now they will fix in between vowels A and E. These are the 3 vowels. So how many places? It will be fixed at the start, in between these 2 A, in between A and E, and at the last after the E. Yes, Pratik, you are right. Answer for the second word channel. So how many arrangements will get whenever they are always together? Arrangements 1, 2, 3, 4, 4 factorial, but A is repeated twice, so 2 factorial into remaining consonants we have to arrange 1, 2, 3, 4, so 4 factorial. So 4 factorial value is 24 into 24 divided with the 2. 24 into 24 divided with the 2. So here we are getting 12. 12 4s are 48, 4, 12 2s are 24 plus 4 to 88, that we are getting. So first answer we are getting total number of ways 2520, and second always together. Now the consonants are never together. Consonants are never together. So total number of ways 2520 minus 288. Again the answer you have to put into the chat box. Again the answer you have to put into the chat box. When the consonants are never together, how many different ways we can arrange the manager word when the consonants are never together. Now next we will move towards next problem. The consonants are never together, how we can arrange this placement word. So letters are more. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 letters. 9 letters are there. So never together formula, never together, we have to get the possible arrangements is equal to total number of ways minus always together. AT means always together, T and W means total number of ways. Yes, Asiya, you are right. 1800 for the channel. So first total number of ways. Count the number of letters. There are 9. So 9 factorial. See, is there any repeated letters? Yes, there are repeated letters. Which one? E is repeated twice. Only E is repeated twice. So 2 factorial. So 9 factorial value we know. How much? 362880 divided with the 2. So you have to count all the values. You have to remember all the factorial values. 362800 2880 divided with the 2 factorial, that is 2. We are getting the answer as 181440. If we divide with the 2, we divide with the 2. So 3618, 2814 and 84 and 0, that is. We are getting the first total number of ways. Now always together. So always together, consonants. Consonants are P, L, C, M, N and T. P, L, C, M, N, T. So how many? 6. 6 consonants always together, and they will take the place in between vowels. Vowels are A, E, E. A, E and E. So how many places? 1, 2, 3, 4. So possible arrangements will get here. Possible arrangements 4 places. So 4 factorial, but E is repeated twice. So divided with the 2 factorial into. These are the 6 consonants. So you have to multiply with the 6 factorial value. Multiply with the 6 factorial value. So do the calculation by using the virtual calculator. Do the calculation. I am also doing the calculations. So 4 factorial value is 24. 2 factorial value is 2. 6 factorial value is how much? 6 factorial value 720. 6 factorial value 720. So by using that, if you solve this, if you multiply 12 with a 720, that we are getting the answer as 8640, right? So always together, and this is total number of ways. So put into this formula total number of ways 181440 minus 8640 minus 8640. So you have to put the answer in the comment chat box. You have to put the answers in the chat box. Put your answers in the chat box. Next question. Now the next question, there are rare possibility this type of questions you will get in the exam, but if there are this type of questions, how to solve that we are going to see. Here not will be focus upon vowels are concerned. They are given the underlined letters that might be contain the vowels and consonants. So how many? 3 letters are underlined, L, O, W. That we have to check that this will not be never together. So never together is equal to total number of ways minus always together. So how many letters are there? 1, 2, 3, 4, 5, 6. 6 letters. So first total number of ways 6 letters. So 6 factorial. But here you can check that O is repeated twice. 1, 2 and L is repeated twice. So 2 factorial into 2 factorial. So 6 factorial value we know. 6 factorial value is 720 upon 4. 18 4 are 720. So we are getting 180. Second, always together. Always together means L, O, W which are underlined, they should be always together. So remaining are F, O and L. So how many places? 1, 2, 3, 4. So possible arrangements will get 4 places, 4 factorial. There is no any repeated letters into remaining these 3 underlined letters 1, 2, 3, 3 factorial. So 4 factorial is 24. 3 factorial value is 6. 24 into 6, that is nothing but 144. So put the values in this formula. 180 minus 144. Put your answers in comment box, chat box. So placement you are right. 8640. Manager, the letter, the word manager you are missing. You are not given the answer. Again you are making some mistakes, Asiya. Total number of ways we are getting 181440. From that you have to minus the always together value. Always together value we are getting 8640. So 181440, 181, do the calculation, 440 minus 8640. You are getting 172880. Please check the calculations and also put the answers for this one in the chat box. Put the answer in the chat box. Now the last type, that is odd and even places. So what is the question? How many different ways the following words can be arranged when the vowels occupy the odd position? Here the vowels, whatever the vowels are present in the word, they will occupy the odd position. Occupy the odd position. So how many are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So places are 1, 2, 3, 4 and 5. So vowel, A is the vowel, one vowel is present. that can be occupy the odd position. So odd position 1, 2 and 3. 3 odd positions are there. 3 odd positions are there. So possible arrangements. We can get 3 places. At these 3 places, 1 that can be fixed. So we know the formula for permutation, NPR, where small n is equal to total number of objects and R is number of objects selected. Yes, Pratik, Asya, you are right. Asya, check for this problem you will got in the placement. That only answer you have to check. So R is the number of objects selected. So what are the arrangements? Ovals occupy the odd position. These are the odd position 1, 2, 3. So 3 odd position. So total number of objects mean 3 odd position. And how many ovals there we have to fix? So number of objects only 1. A is the oval. Into remaining, how many consonants are there? Consonants S, M, R and T. These are the consonants. That will be fixed based on 4 factorial values. Because the 4 consonants are there. 4 consonants will fix based on the 4 factorial value. So in the first part we have seen, whenever we are getting these permutations, how many R value is given, based on that we have to reverse order that n value. So only one time, so 3, only one. So for example I given you that 8p3 means you have to write in the reverse way 8 by the directing that one value. So 8 into 7 into 6. Because what happened? 8 factorial, n factorial upon n minus r factorial. So at the numerator you are getting n factorial, that is 8 factorial. So I will give you how you are getting n factorial upon n minus r factorial. Right. So n is 8 factorial upon n minus r, that is nothing but 8 minus 3, 5 factorial. So if you write 8 factorial value, 8, 7, 6 and 5 factorial, divide with 5 factorial. So this 5 factorial will be cancelled out. That's why I given that you can write 3 times in the reverse. 8, 7, 6. So here only one time 3. And 4 factorial value we know, that is 24. 24 into 3, very simple, 72. So how many possible arrangements we can do when the ovals occupy the odd position? 72 different ways. 72 different ways we can do the possible arrangements. Now next, aptitude, when the consonants occupy the even position. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So how many places that can be there? 1, 2, 3, 4, 5, 6, 7 and 8. 4, 5, 6, 7 and 8. And there the consonants occupy the even position. Even position are 2, 4, 6 and 8. 4 even position. And remaining will be occupied by the ovals. So how many consonants are there? P, T, T and D. So these are the consonants in the aptitude word. And remaining are ovals, A, I, U and E. These are the ovals. So 4 ovals, 4 consonants. Right. So possible arrangements we are getting. Like that. N is 4 because 4 places. So 4 P, that can be occupied the 4 consonants. 4p4 into remaining ovals. How many ovals are there? 1, 2, 3, 4. 4 factorial. But here check that t is repeated twice, 1 and 2. So we have to divide with the 2 factorial. 4p4 divide with the 2 factorial because t is repeated twice into 4 factorial. So 4p4, that is nothing but 4 factorial values, because at the denominator n minus r, 4 minus 4 will be 0, 0 factorial value is 1, and numerator you will get 4 factorial into 2 factorial, divide with the 2 factorial into 4 factorial. So 24 into 24 divided with the 2. So 12 into 24, that we have done earlier the calculation, 288. 12 4s are 48, 8 we are written, 4 remaining, 12 2s are 24 plus 4 28, 288, that is the answer. So aptitude word that can be arranged when the consonants occupy the even position, how many times? 288 times. So we have seen all type 5s in the word. Also we have seen the number problems with 0 and without 0. Now we are going to discuss some expected questions for the GATE or other technical exams based on the numbers and words in the next lecture. Hope you have enjoyed this session. If you are enjoyed, put into the chat box. You can like this video and don't forget to subscribe our